Hi everyone, I thought I'd do this last video with you as, the last example with you as a video just for something different, and sometimes that's easier to follow through the working. So let's have a little look at this problem. So we've got a rugby player here. They take a penalty kick and they kick the ball at 18 meters per second at an angle of 48 degrees. And the question A says, what are the vertical and horizontal components of the ball's motion? So first thing I'm going to do is draw a picture. This is 18 meters per second and we've got an angle of 48 degrees. And so the first thing I'm going to do is draw my right angled triangle with my horizontal and my vertical velocity. It doesn't matter whether you call them Vx and Vy or Vh and Vv, that doesn't really matter. So the horizontal velocity is 18 cos 48, which is 12.04435, or 12 meters per second to two significant figures. And the vertical velocity is 18 sine 48, which gives us 13.3766, or 13 meters per second to two significant figures. Now there's a reason I've written all these numbers in, okay, because we want our answers to be as accurate as possible through the question. So if we're using these numbers in any other part of the question, I'm going to use the unrounded one, because that is going to make my final answer more accurate. So let's have a look at part B. How long did it take for the ball to reach its highest point? So we're looking for a time. And because the ball is going up in the air, we know that the acceleration is 9.8 meters per second. And because that acts in the downward direction, down, if you think about the axes on a maths graph, down is negative. So it's negative 9.8 meters per second. And because we're talking about the highest point, that we are going from here to here, we need the vertical velocity. Okay, so the initial vertical velocity is 13.3766. So we don't use 18. Okay, because we're looking at the time to the top, and we know that the velocity at the top, the final velocity, is 0. Okay, it's still accelerating at the top because it's changing direction, but it's the magnitude of the velocity is 0. So how long will it take? So we're going to use Vf equals Vi plus At. Okay, not quite in the order of guess because I've put the unknown first, but we're pretty close. So Vf is 0, Vi is 13.3766 minus 9.8 T. Okay, and if you work, so what I'm going to do if I put my brain box in there is to add 9.8 T to both sides. So I get 9.8 T equals 13.3766. Then I'm going to divide by the 9.8, and I get T is 1.36496, or 1.4 seconds to two significant figures. Again, this is my final answer, but if I need to use that time again in the question, I'm going to use the unrounded one. Okay, so that's the answer to B. Let's have a look at C. What height? So we know how long it takes to get to the highest point. Now what we're looking for is, what is this height here? Okay, so we've found T here in part B. Part C is about finding the height. So we know that T is 1.36496. We know that Vi is 13.3766. We know that the acceleration is minus 9.8. And we know that VF is 0. I'm just going to change pieces of paper here. So you can still see that, that's good. So I'm actually going to use D equals VI plus VF over 2 times T, which, so I don't really need the acceleration there. So I'm going to use VI is 13.3766 plus 0 divided by 2 times 1.36496. So if I do this part first and then multiply by this, I'm going to come out at 9.129. So to 2 significant figures, it's 9.1 metres. That seems reasonable, that a rugby ball would go 9.1 metres in the air, so I'm quite happy with that answer. It seems reasonable. Let's have a look at part D. How far down the field will the ball have travelled when it is at its highest point? So what it's looking for is when the ball is at its highest point here, what's this distance? Okay, now this distance, to get this distance, it's the horizontal distance, so we would use the horizontal velocity. Okay, and as you might remember, in the horizontal direction there are no external forces acting. So because there are no external forces acting, we can use this formula here. Okay, so I'll just write that, no external forces, so therefore there's no acceleration. Okay, so that means those 3 dots mean therefore no external forces, therefore no acceleration. So the distance is going to be the velocity times time, which is horizontal velocity, 12.04435. I'll just write that in there actually. And it's that multiplied by 1.36496, which is the time it takes from our answer back here, the time it takes to get to the highest point. Okay, and that becomes 16.44, or 16 metres to 2 significant figures. And then part E for experts is asking, it's saying if the goalpost is 35 metres away, will the ball clear the crossbar? So let me just draw this in again. At the halfway mark, the ball is 16 metres. So once it's travelled its entire range of motion, it's going to have covered 32 metres. The goalpost is 35 metres apart, so the answer is no. The ball will only get 32 metres, so will fall short of the goal. That's an excellence part of a question there. Okay. And yeah, so that's the answer to that example there. So I hope that's been helpful. Please rewind me if you need to go back over a certain section. Thanks.